So in our quadratic formula, which again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the part that's underneath the square root, so the b squared minus 4ac, that has a special name. It's called the discriminant. Now, it comes from the word to discriminate, which generally has a negative connotation in our society, but the definition of that is to separate out. And so in this context, what the discriminant does, what this b squared minus 4ac does, is it determines for us how many and what kind of answers the equation is going to have, because it's underneath the square root symbol. So if that number turns out to be positive, when we do the b squared minus 4ac and we get a number greater than 0, so we get a positive number, that means that we are going to have two real answers. They might be integer values, they might involve square roots, but they're going to be real numbers. There's not going to be a negative underneath the square root symbol, which gives us an imaginary. So we're going to get two real numbers. If that part underneath the square root symbol, that discriminant, equals 0, so it exactly equals 0, well then we're only going to end up with one answer. And the reason for that is when we take the square root of 0, we get 0. And then remember, whatever we have underneath the square root symbol, we're going to add or subtract it from that negative b. Well, whether I add or subtract 0 doesn't make a difference. I get the same thing. So that's why we just basically end up with negative b over 2a, which is the one answer. And then finally, if that b squared minus 4ac, if the discriminant is a negative number, if it ends up being less than 0, then we're not going to have any real answers, and instead we're going to have two imaginary answers. And so we have experience working with imaginary numbers, so we can still solve the problem. It's just that we'll have an I in our answer, but we'll have two imaginary answers. So let's put that into practice with the examples that we see here. So for the first one here, it's written in my standard form where everything is piled up on one side. So I can go ahead and work on b squared minus 4ac for this one. So b in this case is negative 6. So I've got negative 6 squared minus 4 times 1 times 9. So negative 6 squared is going to give me 36, and then minus 4 times 1 times 9. So 4 times 1 is 4, times 9 is 36. So I'm going to get a discriminant of 0 on this one. And so what that tells me is that I only have, if I look up at the different options here, I only have one answer to this question. That does kind of say answer. So if I want, I can continue to go ahead and solve through the rest of the problem by using the full quadratic formula. Now, I've already done part of the work since I've done the b squared minus 4ac part, so I just need to fill in the rest. So negative b, so again, b is the number in front of the x, so I've got negative 6, so 6 plus or minus the square root of 0 divided by 2a, so 2 times 1, which is just 2. And so as you can see, the square root of 0 is just 0. So this part just kind of evaporates from our problem here, since adding or subtracting 0 doesn't change anything, and we just end up with 6 divided by 2, which is 3 for an answer. So for the second one, again, we do have to verify to make sure that it's set equal to 0 before we can start to use those coefficients a, b, and c in our discriminant formula. So b squared minus 4ac in this case is going to be negative 3 squared, so that's b squared, minus 4 times 2 times 7, so 4 times a times c. So we've got negative 3 squared is 9 minus, and then 4 times 2 is 8, times 7 is 56. So 9 minus 56 is going to give us a negative 47. And so that means, if I look here, I've got b squared minus 4ac is a negative number, so I'm going to have no real answers. Or I could say that I'm going to end up with two imaginary, or two complex would be another way that we could describe it. So if we go ahead and finish things out then, so we've got x equals negative b, so b is negative 3, so negative 3 becomes 3, plus or minus the square root of negative 47. So we're not adding any extra work by checking this discriminant. It's just we're doing that part of the formula in advance. And then in the denominator we've got 2 times a, so in this case that's 2 times 2. So with the square root of negative 47, we have experience with this, so we have to separate that root negative 1. So I think of this as root 47 times root negative 1, and then of course root negative 1 gets swapped out for I, and then root 47 can't be simplified at all. So if we scroll down a little bit here, give ourselves some room, we end up with x equals, so I've got 3 plus or minus, and then I'm going to write it as square root of 47 times I, just making sure that that I is not underneath the square root symbol, and then that's going to be all over 2 times 2, which is 4. So we have our answer here, 2 imaginary answers, because the part underneath the square root symbol, the discriminant, turned out to be negative. And so for the last one, we see even though we're missing the c in our equation, it just means c is going to equal 0, we can still use our discriminant to figure out how many and what types of answers we're going to have. So b squared minus 4ac, in this case, b is 10, so I've got 10 squared minus 4 times 1 times c, again, since there's no number being added or subtracted at the back end, c is going to be 0. So 10 squared is 100, minus 4 times 1 times 0 is 0, so we get 100 as our discriminant. And so since that's positive, that falls into this category here, where we're going to have 2 real answers. And so then to finish things out in our full formula, we have x equals, and then negative b, so b is 10, so that becomes negative 10, plus or minus the square root of, so b squared minus 4ac, we just found that that equals 100, and then all over 2 times a, so 2 times 1, so we just get 2 in the bottom. So we've got x equals negative 10 plus or minus, now the square root of 100 is 10, and then that's still all over 2. So we're going to be able to perform these operations, so I can go negative 10 plus 10, so that's 0, and then 0 divided by 2 is just 0, and then we've got negative 10 minus 10, so that's going to give us negative 20, but then I still have to divide that by 2, so negative 20 divided by 2 gives me negative 10. So my 2 answers in this case are 0 and negative 10. So again, the discriminant is used to determine, to predict how many and what kinds of answers we're going to get. If it's positive, we're going to get 2 real answers. If it's 0, we're going to end up with just 1 answer. And if that b squared minus 4ac is negative, then we're going to have no real answers, and instead we're going to end up with 2 imaginary results.